Welcome to this lecture. So in that lecture I talk about perturbation theory, that is degenerate perturbation theory. Now in this lecture I am going to talk about perturbation theory, and I will use perturbation theory to study the Stark effect in hydrogen atom, right? So let me write down the title of my talk. Title of my talk is Stark effect in hydrogen atom using first order degenerate perturbation theory. So this is the title of my talk or lecture. So let us start. As we know that for n is equal to 1, there exists only one state, that is NLM, or it can be represented at 1, 0, 0 state, and this state is non-degenerate. But if I talk about n is equal to 2, means I want to study the Stark effect in hydrogen atom, but using degenerate perturbation theory. So if I try to look at n is equal to 2, then there exist 4 possible states, that is NLM. It can be represented as Z2, 0, 0, 2, 1, 0, and 2, 1, 1, and 2, 1, minus 1. So these are the 4 possible states, and that means this is the ground state of hydrogen atom, and this ground state is non-degenerate. But if I talk about first excited state, then this first excited state is fourfold degenerate. This is fourfold degenerate, and the energy corresponding to this excited state is E2 is equal to minus Ry upon 2 square, and it is equal to Ry upon 4, where Ry is the Rydberg constant and its value will be 13.6 electron volt for the hydrogen atom. Sorry, not for the hydrogen atom, but its actual value is 13.6 electron volt. And when external electric field is applied, that is E, and this electric field is applied along that axis. Now the perturbed Hamiltonian corresponding to this applied electric field, it can be written as E epsilon Z cap, right? So that's it. So now in general, the elements of this Hamiltonian are given as it is 2L prime M prime over HP. It is 2LM and it is E epsilon 2L prime M prime. It is Z and 2LM, right? So in matrix form, it can be written as we can write as HP is equal to it is 200 HP, then 200 HP, 211, and then 200 HP, 210, then 200 HP, 21 minus 1. This is a determinant. This is one row. Now let me write down other rows. It is 211 HP, 200, then 211 HP, 211, then 211 HP, 210, 211 HP, 21 minus 1, then 210 HP, 200, 210 HP, 211, 200 HP, 210, sorry, it's 210, right? And then 210 HP, 21 minus 1, and here it is 21 minus 1 HP, 200, 21 minus 1 HP, 211, 21 minus 1 HP, 210, and then it is 21 minus 1 HP, 21 minus 1, right? So this is the determinant, sorry, this is the matrix for this Hamiltonian, not a determinant, right? Now in simple form, this can be written as this is equal to, in simple form we can write down it as right. So this is another way to look at this matrix. This is just for the sake of simplicity. So that's what we can write down it as. And as I know that this HP means perturbed Hamiltonian is E epsilon Z. If I use this here, then this Hamiltonian can be written as E epsilon right. So this is another way to look at it. So if I use selection rules, means using selection rules and symmetries, property of symmetries, we can say that states which couple with 2s and 2p states are non-vanishing and rest are vanishing. So if I use this idea, so then I can say that these 200 Z2100 sorry 210 is and 210 Z200, these are non-vanishing and their value is, we can write down this value or we can learn that how this value can be calculated. You can follow the problem of hydrogen atom in any book. So that means the value of these two will be 3a0 and rest terms are 0 other than these two. So that means perturbed Hamiltonian, it can be written as like this HP is equal to minus 3e epsilon a0. It is 0 0 1 0 0 0 0 0. It is 1 0 0 0. It is 0 0 0 0. Right? So that's what is going on here. Now to calculate the eigenvalues. So to calculate the eigenvalues, so consider eigenvalue equation, that is HP minus E2n1, its determinant is equal to 0. That means I can say that minus 3e epsilon a0, it is 0 0 1 0 0 0 0 0 1 0 0 0 0 0 0, right? And minus E2n1, it is 1 0 0 0 0 1 0 0 0 0 1 0 0 0 0 1, and the determinant will be equal to 0. So if I simplify it, then it simplifies to minus E2N1. It is 0, and let me call this as x. So if you call this as x, then let me write it as x, and then 0, it is 0 minus 2 and 1, it is 0, it is 0, then it is x, it is 0, it is minus 2 and 1 is 0, and then 0, 0, 0, minus E2N 1, and the determinant will be equal to 0. Let me simplify this determinant. So operating along this, so if I operate, it will be 2 and 1, determinant will be rest part, so it is minus 2 and 1, 0, 0, 0 minus 2 and 1, 0, 0, 0 minus E2 and 1. So it is a diagonal matrix, right? And then operating along this, it will be 0. Now I will operate along this. So it is plus, minus, and then plus. So it is x, and if I did this, then it will be minus 0 E2 and 1, 0. It is x, 0, 0, 0, 0 minus 2 and 1, and this is the determinant. So it is a diagonal matrix, so that means minus E2N 1, sorry, and whole raised to power 4. It is the value of this, because this is a diagonal matrix, and these are 4 terms, and then plus x, and operating along this only, and here it is minus E2N 1, determinant will be x, 0, 0 minus 2 and 1, and this will be equal to 0. Now it's equal to E2N1 raised to power 4, and if I simplify it, then it comes out to be minus x square E2N1 its whole square, and it is equal to 0. Now I can take it outside. E2N raised to power 2 can be taken outside. So if I take it out, it is E2N1 whole square minus x square is equal to 0. It means this is possible if 2 and 1 its whole square is equal to 0, or E2 and 1 whole square minus x square is equal to 0. So that means now I am getting two values of this 0, 0, because it is a quadratic and it's also quadratic. So from here I can say that it's two values plus minus x, or I can say that plus minus 3 e epsilon a naught, or it is minus plus 3 e epsilon a naught. So that's what we are getting. So it means there are 4 possible values. Thus, there are 4 possible values E2 and 1 is equal to minus 3 e epsilon a naught plus 3 e epsilon a naught, 0 and 0. These are the 4 values. So that means there are 2 states whose value of energy will remain the same, but other 2 states will change their energies. So let us try to understand this graphically. So graphical representation. So say it is a one energy level, and this energy level will remain as it is, but when field is applied, let me say electric field, it is without field and it is with field, and here we have applied the field. is this is the weak field which we have applied here. It is electric field. Now what will happen? It will split into two levels, right? So on the application of this field, this will split and we are getting these two energy levels. And its energy will be energy corresponding to it. It is E2 means minus 13.4 by 2. Sorry, 13.6 upon 2. And it is 3.4. Its value will be 3.4 electron volt. Now what will happen? It is minus, and say here it is the zero level. Here this energy level is minus 13.6, or sorry, it means it is minus 3.4 electron volt is the energy of this level, and these two levels have the same energy. So E20, let me call this as E20 corresponding to unperturbed system. So this energy will change by this, means it is either this E231. The value of this will be 0 or this will be 0, as there are four possible values. And this will also change E20 plus E21, and the value of this will be E20 plus E24, because we are having four possible values, because E21 which we have calculated is equal to minus 3E epsilon A naught, and the value of E214 is equal to, it is 3E epsilon A naught, and the value of these two will be equal to 0. Or in other words, I can say that if I talk in terms of numbers, then its value will be 3E epsilon A naught, and its value will be minus 3E35. Sorry, not 35. 13.6 upon 4 is let me do one thing. 13.6 upon 4, yeah, it is 3.4. sorry, so I have written wrong value here. So it is 3.4 minus 3E epsilon A naught. So that means what is going on when field is applied, then this field or we can say that this perturbation has partially removed the degeneracy of N is equal to 2 level, that is two states have same energy as clear from this point, and other two states will get splitted on the application of this, right? So with this article will be closed, and we have seen here that how energy will be split. It means how degenerate states will split up on the application of electric field, right? So thanks for watching this lecture.